Meet Albina, a young woman living in the capital city of Ghana. Just 2 months ago, on the 22nd of May, her property was damaged in a flood which came as a complete shock to her. Albina is not the only one who lacks advanced flood warnings. In fact, in a survey of 369 households in Accra, 60% were unprepared for flood disasters. To make matters worse, a future with increased frequency and intensity of floods has been projected. Our solution is to use data collected from rainfall and flow rate sensors, powered by piezoelectric material to predict the likelihood of a flood. How will our sensors work? A voltage signal is generated by the piezoelectric material when under mechanical stress. The voltage produced over a given time frame can be used to determine the precipitation levels or the water flow rate. Rainfall sensors will be installed in public places. Flow rate sensors will be installed and placed in pipes. The collected and analyzed data will then be presented in real time via a free app. If the flood risk exceeds a given threshold, the app will alert citizens and warn them how long they have to evacuate. GARID, a government initiative, is tasked with improving flood warning and response capacity in Accra. To achieve this, devices such as tipping rain bucket gauges and velocity radar sensors are being used. The low cost of piezoelectric material makes large-scale implementation of our sensors possible and also more financially sustainable than the devices GARID currently uses. By forming partnership with GARID, we can provide a larger set of data on rainfall and water flow rates. Our data can then be implemented by GARID's early flood warning systems. This will also allow us to utilize the data analysis systems that already have been put in place. We also plan to diversify to secondary markets targeting three specific customer segments: insurance companies who need to reduce risk and potential payouts from flood damage claims, telecommunication providers who aim to enhance service reliability by mitigating flood risks, and finally, agricultural tech companies who seek to optimize agricultural practice and mitigate flood-related crop damage. Through funding, year-long government contracts, and licensing data to secondary markets, we calculate that we will offset costs associated with our solution. By our third year, we project to have perfected our solution and will be ready for initial rollout. In the long term, we plan to expand to other cities and develop add-ons to the sensor, such as a pH probe for agricultural use. Overall, the value of our proposition lies in a precise solution which will help fill the gaps in the city's flood data, easy scalability, the solution being adaptable to local conditions, and the simple integration of data collected into future city planning and current city maintenance. Our team's unique combination of insight and experience makes us the ideal team to develop and deliver this product.